So this is from GATE 2021. In the circuit shown, a 5 volt Zener diode is used to regulate the voltage across the load R0. The input is an unregulated DC voltage with a minimum value of 6 volt and a maximum value of 8 volt. The values of RS is 6 ohm and the Zener diode has a maximum rated power dissipation of 2.5 watt. Assuming the Zener diode to be ideal, the minimum value of R0 is. So given the input voltage Vi varies from 6 to 8 volt, RS is 6 ohm. The Zener diode has a reverse breakdown voltage of 5 volt. And we need to find what is R0. And given the Zener diode has a maximum power dissipation of 2.5 watt. So Pz max, which is the power dissipation across the Zener, is maximum is 2.5 watt. So we know this is equal to the Zener voltage Vz into the maximum current which flows through Zener, that is Iz max, right? So which is equal to 5 into Iz max. So from here the Iz maximum current which can flow through the Zener is 2.5 by 5, that is 0.5 ampere. Okay, which means if this is the Zener current and the voltage across the Zener diode Vd, okay, and Vz is actually the Zener breakdown voltage, right? So the graph, the Vi cara will be like this. So at Zener Vz voltage there will be the breakdown happening, right? And here the minimum volt current is this one. Minimum current at the breakdown is this one, that is Iz minimum, and the maximum will be Iz max. It depends on the maximum power rating which is given here, right? So this is Iz max, and given this Iz max is now it is 0.5 ampere, and we know the minimum current. So minimum current is actually this one. So even though it is micro ampere, we can set it as 0, approximately equal to 0 ampere. So Iz minimum of the Zener will be approximately equal to 0 ampere, right? Now if we see the circuit, the current, input current, I will call it as say I in, that is split into current through the Zener, that is Iz, and the current through the R0, that is I will call I0. So I in is equal to Iz plus I0, right? And what is the minimum current I in, or the maximum current, since this is maximum, right? So we will see what is the maximum current I in, that is equal to Iz max plus I0. Why I0? Because R0 is actually a fixed resistance that we need to design and set, and the output voltage V0 across the Zener, the R0 is same as Zener, which means since R0 is set, I0 should be also fixed. The current flowing through R0 should be fixed. So I0, right? So Iz max plus I0 is the I minimum, I in maximum, and I in minimum is equal to Iz minimum plus I0, that is the minimum and maximum current of input. So the question is to find the minimum value of R0. So what is the minimum value of R0 which we can design here and connect it, so that even the R0 is minimum, I will get the Vz to be 5. So which means if R0 is minimum, if I have minimum current I0 min flowing through R0, then I0 min into R0 should be equal to 5, right? That is a condition. So at what value of voltage Vi does the minimum I0 comes? So that happens when a minimum I in current flows through, right? Because Iz can vary from 0 to 5. So I0 can be minimum only in this condition, that is in the condition when I in is minimum. So what is the value of I in minimum? This is equal to when the this voltage is fixed, right, 5 volt. So when this voltage is minimum, this voltage is minimum when the Vi is 6, right? So 6 minus 5 by the resistance Rs, that is 6, that is 1 by 6 ampere. This is the minimum current which can flow, right? So I in minimum equal to 1 by 6 ampere. This is equal to Iz minimum. Iz minimum is 0 here, right? 0 plus I naught, right? So I naught is actually 1 by 6. So V naught should be equal to 5 even if I naught is equal to 1 by 6, right? So I naught into R naught. So 1 by 6 is I naught, that into R naught. Even in this condition, the voltage V naught should be 5. So what should be the R naught minimum? R naught minimum will be equal to 5 into 6, that is 30 ohm. Right, so the answer is 30. So if I set the R naught to be 30, even if Vi is 6, the current Iz will be set to 0, right? Automatically it will adjust to 0 and a current of 1 by 6 will flow, and 1 by 6 into 30 will be equal to 5. And now if voltage Vi is 8 volt, the current In will increase. So what happens? The extra current apart from 1 by 6 will flow through the Zener diode, right? And 1 by 6 will be retained at the output. Then also I'll get 1 by 6 into 30. So the minimum value to get a 5 volt at the output is 30 ohm. So this is a question from GATE 2021. The question is, in the circuit shown, the input Vi is a sinusoidal AC voltage having an RMS of value of 230 volt plus or minus 20%. The worst case peak inverse voltage seen across any diode is. Okay, so given this Vi is having a Vrms of 230 volt plus or minus 20%. Right, so maximum will be 230 into, so Vrms max is 230 into 1 plus 20%, right? 20 by 100. So this will be equal to 276 volt, and Vrms minimum is 230 into 1 minus 20 by 100, right? Equal to 184 volt, right? Now the question is to find the worst case peak inverse voltage across the diode. So here if you see this part, this is actually a bridge rectifier, right? And we know for bridge rectifier, the peak inverse voltage is actually equal to Vm, where Vm is the input voltage, a peak of the input voltage, right? Vm minus Vm. So what is a peak of input voltage? That is its peak inverse voltage. So what is the peak of here input voltage? The peak of input voltage, that is equal to Vm, that is equal to Vrms into root 2, right? So Vm by root 2 is actually Vrms, so Vrms into root 2. So here we need to find maximum value. So we should take Vrms maximum, that is 276 into root 2. So this will be approximately equal to 390 volt. So answer is 390. Yeah, so the question is for the network shown, the equivalent Thevenin voltage and Thevenin impedance as seen across the terminal AB is. Okay, I need to find what is the Thevenin voltage and Thevenin resistance across this A and B. So here A and B is open and a source is applied 5 ampere. So the current flowing here will be 0 ampere, right? So the drop across this is 0 and there will be a current flow like this, and this is equal to 5. So I1 is 5 ampere, right? So if I1 is 5 ampere, the voltage drop across the 10 ohm is this plus minus, that is voltage across 10 is 10 into 5 equal to 50 volt, right? Now since this is 50 volt, What's the VA here? VAB is equal to the voltage across this 10, that is 50 plus the voltage here, right, 3I, so 3I1. So 50 plus 3 into I1 is actually 5. So 50 plus this is 15. So 50 plus 15 is 65 volts. So VAB is actually 65 volts. So answer must be B. So we'll also find the Thevenin resistance here. So to find the Thevenin resistance, we'll remove the current source. So this 3I1, this resistance 2 ohm, this is 10 ohm, this is A and B. So to find the Thevenin resistance here, this is a dependent source, right? So we need to apply a voltage Vs, a reference voltage, and the current is Is. So the Thevenin equivalent resistance RAB will be equal to Vs by Is, right? So since this is the current Is, this will flow like this, right? So there will be a voltage drop across the 2 ohm, there will be a voltage drop across 10, right? And given the current, this is I1, or yeah, right? So applying KVL here, from the source it is like Vs minus Is into 2, that is voltage across this 2 ohm, and then I have 3 ampere, so plus 2 minus, right? So minus 3I1, and there will be voltage drop across 10 plus minus, so minus 10 into I1 equal to 0. So here from the circuit it is clear that Is is same as I1, right? Because the same current flows like this. So I can write Is equal to I1. So this is actually 2I1. So 2 plus 3, 5, 5 plus 10 is 15. So 15 I1 is Vs, and this is equal to 15 Is. So what is Vs by Is? Vs by Is is 15 ohm, right? So the answer is B.